Good evening. We'll start in a couple of minutes, okay? Hello, can you see my screen now? Can you see my PPT?
Yes, sir.
Okay. Okay, we'll get started then. Yeah, good evening. Welcome to week 9 of this course, Optimization Methods for Civil Engineering. So, we'll be going through the problem solving session for the topics that have been taught in week 9. So yeah, this is Diljit and we'll be starting the session. So in this session, I think you have gone through the lectures. So sir has given introduction to the software called R. R is a statistical software used for statistical analysis. And I hope you know how to install R and then R Studio. Uh, I think sir has shown that in the like lecture 2022, I think 22 or 23. So I won't be showing the installation of the software, so I hope you know that, and I'll now proceed to first I will show some basic commands and solve one or two, three basic questions, and then we'll solve problems from genetic algorithm. Okay, so yeah, first coming to like these are some of the commands. Okay, let's get started with the interface of R. Yeah, can you see my screen of this R Studio now?
Yes, yes.
Okay, yeah, I hope the letters are visible, or should I increase the size?
Okay, little increase, sir.
Okay, okay, fine. I'll just increase the size by.
Sir, is there any advantages to take the R software, sir, for the analysis?
Yes, yes, yes. There are advantages.
Okay, when compared to other softwares like MATLAB.
Yeah, the thing is that R is very good for statistical analysis. One thing is
Okay,
there are a lot of I think Sir has told about these packages and libraries. So you can use Python also, but the thing is that in Python is like use a very this one. diverse kind of software. So in Python, there are people do a lot of work. People do machine learning. People do this data analysis. People also do this plotting of graph, plotting, and then AI and this kind of things. But R is what it is targeted for statistical analysis, and it is targeted for this machine learning, mainly for numerical problems. Okay, and this is one thing. And when there are numerical problems, so there are some packages in R which are like properly developed. The thing is that you need not write your own code every time to like do some of the use some of the functions or some of the methods that have been already defined. So that is the advantage. You can directly load that package, you can use the function in the package, and then you can use that function for your work. That is one advantage of R. And there are a lot of such functions in R that are used for this numerical and mathematical statistical analysis. This is one thing. You can use Python also, not a problem. But the thing is that yeah, MATLAB has very less amount number of functions, like less number of packages compared to R and this one, R and Python. And one more thing is MATLAB is not open source. Python and R are open source. That is MATLAB. You have to get the this one licensed version of MATLAB. You have to buy it. It's not free of cost. And R and Python are free of cost. You can install it anytime. You can delete it anytime. It's like that. And all the packages, everything are free of cost. In MATLAB, it's not free of cost. And one more very important thing is community. There is something called R community, and also there is something called Python community. So that when there is a community, it's like if you go to Google and you are facing some problem in your code. So when you go to our community, you can just plot like give your problem that I am facing some issues with my code. You can give the what are the problems, what are the problems you are trying to solve, what are the issues that you are facing, and if you pose that problem, people will be giving their answers. So the community is very large in terms of R. Lot of, because R is open source and many people are using R all over the world. So people, somebody or the other have faced a similar kind of problem before. So if they have faced the similar problem before, they have find some problem, they find some solution, and they will be telling you the solution. That is one of the main advantage of R. And other thing is in MATLAB, the thing is that when you're running big codes, like these are very small codes, but if you're running very big codes, in that case, MATLAB consumes a lot of memory, that is in your RAM, in your computer. So your computer might get lagged, or it might sometimes hang also. But R is very good in terms of that. It doesn't consume that much of memory compared to MATLAB, and it is good for running big codes. Okay, so these are the main advantages. And when you're running R, so always try to use this IDE called Rstudio. Always download Rstudio, and on the background it will be running R software. So Rstudio is very convenient to use because it has this interface. There are four screens you can, as you see, this is the first screen. The first screen is called editor screen. You can write your script here, whatever like code script you want to write, you can write your script and execute the script. The second in the bottom is the console. It's like similar to this, that MATLAB command prompt, not command prompt, MATLAB this one, I think a command line or something like that. Yeah, so it is similar to that. You can write what like execute one line of code or one line of some, you want to see some variable, you want to see some uh, you can execute just one line of your code, or just want to see some variables, visualize some data frames or variables, then this command line is there. And this is the third one. Third window is for visualizing your functions, the data frames, the vectors, arrays, everything that are used in your code. And lastly, this window is, you have different things. There are like, one thing is the files, like what are the files. If you load one directory, like load one folder from your system, it will show all the files that are in that system. So you can in that folder, so you can see which are the files in that folder, and you can just see like open your code or your script or your plots, anything here. Then you can visualize your plots here, whatever your plots you do, you can visualize here. This is called packages. What are the packages that are available, and what are the packages you have downloaded, and what are the packages you are using in your code, you can just see in this. There is also something called help. In help, like if you are facing some issue with some facing issue with some code, or you're facing some issue with any of the functions, or you need some help, you can just type the name of the function or type the name of the command, and it will show that what is the use of the command, how is the like function used. It will give all the details. Like this is the, suppose this is, I have searched GA. GA is genetic algorithm. So if you search GA, it will give one description, that is what is GA, how it is used. It will give a description of the function, like what is the function, what are the different parameters that are used in the function, and it will give details of the function arguments, that what are the different parameters in the function. It will give details on that. Suppose type, what is type, it will show details on the type, what you can input in this type parameter, fitness, population, everything. So it give details of everything all, and it sometimes it will also give one or two examples also. Yeah, it will give show one or two examples how to use the function. So this is very helpful when you are some very new to software. If you just type the help, it will show the command, it will show one or two examples. You can use the, like, you'll get an idea how to use the function in your code. And it will also give some references. So these references are like give some papers or some books, so you can follow these books to see like from where the this function or this method has been picked up, and you can get the algorithm or the like the concept behind these functions. There is this viewer window. This is again used for like viewing your data frame and scale, something called presentation that won't be of much use as of now. Okay, so we'll keep it to plots. So I have installed RStudio, and you can, I know you have how to install. You can, if you haven't installed, you can just go to YouTube and just search how to install RStudio. It will be a 3-4 minutes video, small video. You can just follow that and install RStudio in your computer. Okay, now when we are talking about any software, be it R, MATLAB, or Python, there are mainly four, not three, yeah, four types of data, like data types. One thing is scalar value. Scalar is like one, two, or any one, A, B, C. Like there is only one value is there, then it is called a scalar. And the second thing is a vector. So this is a vector. Vector is like when there are like in a particular line there are more than one more than one variable, more than one value. So this is suppose here a, I, the way of creating a vector in R is this: a is equal to c. Suppose you want to write, or you want the elements of the vector to be 1 2 3 4 5. There are 5 elements. You write a, and this is the assign symbol. You can see here, this is the assign symbol, like less than and minus. This is called a assign symbol in R. You can also use equal symbol, like in MATLAB we use the equal symbol. You can use the equal symbol here too. But thing is that sometimes when you're operating with categorical variables, like when the variables are not numerical, so you are using a b kind of thing, or there are some like different, like this one thing, when you're using classes, or when you are using this kind of variables, cells. There's something called cells, so they're very higher order variables. So if you are using those kind of variables, in that case sometimes using equal might create some issues in your code. It might not be able to take into, like, do the operations properly. So it is always convenient to use this symbol. This symbol will be used everywhere in R, and this is the most widely used symbol for assigning a value to a variable. So we have given, assign, this is a vector, we are assigning this vector to the variable a. So just see when we write c means it is creating a vector. Okay, so you can see here this vector is created. It is a numeric vector. It goes from 1 to 5. Secondly, okay, we have created this vector. Now suppose there is another way of creating vector. Suppose you have a very long vector, it goes from 1 to 100 or something like that. So in that case, suppose I have like 25 here. Okay, and so you need not write 1 2 3 4 to up to 25 every time. So it's like you give the initial, you give the last value, the first value, last value, and how the increment, what is the increment between each of the increment, the difference between each of the value. So I have given by equals to 1. So just this is a sequence command. This is also used for creating a vector when you are having a long vector. So you can see it goes all the way up to 25. If you type here just a and put enter, you will get 1 to 25. Yeah, and one more thing, suppose I am running, suppose each line of code. So if you have to run only one line of your code in this script.
How to get the result in the bottom window? You have to run every time.
Can you repeat?
No, now this time, just like that, it has come in the bottom window. It's showing 1 to 25. It has enter after.
Yeah. It's just like the thing is that suppose you have executed something, okay? You executed this line of code. You executed this line of code. How to execute? Just you can keep your cursor here, or you can just select this whole line of code, and you have to press Ctrl and Enter together. You press Ctrl Enter. You can see that this line of code has been executed. You can see this line of code has been executed. This means that there are no errors in while executing this, and this has been executed, and so a variable a has been created that is coming in this environment, this window, this variable window. Now if you want to see all this, here you can see it is showing up to 10 because it is inside that variable. So if you want to see all the values inside a, just type a and just press enter. Just put enter and you can see all the values of a are being displayed. Okay, this is how. Suppose okay, if I say by instead of equalizers put something like plus. Okay, so this should give an error, right? We will see how the code is executed. You press Ctrl Enter, you can see error in in by plus one non-numeric argument to binary operator. So this there is an error in this symbol plus, so you have to use equal to only. So these are things. So this is the error. There are different types of error. Based on a type of error, you have to identify what is the problem in your code. These errors and all, I won't be going too much into detail now. There is something called value error. There is something called name error. There is something called this non argument assigning error. This error is called non-numeric argument to binary operator. Here there is a problem in assigning the command to byte. So there are different types of errors. So these are you can learn if you just go to just type help like this one tutorial to RStudio. If you type in Google, RStudio has developed a documentation for them for their software, and it will be visible as a PDF. You can see the PDF, or else you can also see tutorials in YouTube. So this is again, if you want to do the increment by 0.5, you can do this. You can sequence 0.5. Yeah. Now you can see the variables are created at an interval of 0.5 from 1 to 5. Now if we have to suppose, this is again one similar way of like, if you want to just integer increment, you can simply write a is equal to 1 to 7. This will give all the integers from 1 to 7. And now if we have to like extract only one element of this vector, suppose we want to get the second element. The second element is like you just give a square bracket of 2. So if you give this, it will get the second element. You can see a of here it is coming 1.5, and here you can see the second element is 1.5. Okay, so this is how you create a vector in R. You can extract the elements, so like first, second, third, fourth, like the elements in R. And lastly, yeah, these are the how the commands for getting a vector. Okay, now second thing is creating a matrix. You know how it is a matrix, how a matrix is the operated. So the syntax is you have to write matrix, the data, there are values in the matrix, number of rows, number of columns by row, and dimension names. If you want to give the dimension names, it's okay. If you don't want, it's not required. Suppose now this is a want to create a matrix A in this format from 20 to 25. There are 6 values in this matrix, and we want 3 rows and 2 columns. Okay, so we will press enter, control enter, so not enter, control enter. We will get a. So let us see how is a is coming. If press a in command console, and if you press enter, you can see. So this is the matrix A. You can see we have given that 3 rows and 2 columns. So now we haven't given this command, okay, by row equals to true or by row equals to false. So by default, by row, this command is set to false. What this means that whatever values are there we have given, suppose 20 to 25, the sequence in the sequential order, the first 3 variables will be assigned to the first column, the next 3 variables will be assigned to the second column, and if there are more variables, it will be assigned to the column wise. All the variables will be assigned column wise if we don't give this by row equals to command. Okay, now let us see. You have seen this, now let us run this second line of code. We have given by row equals to true. When we give this, we have got the matrix A. Now we will see. Can you see the difference? You can see now 20, 21, 22, 23. From the elements are created row wise. First two are in the first row, then the second row in the second row, then the third values are in the third row. Okay. So this is the command, how the by row command is used in creating a matrix in R. Okay, this was about creating a matrix. Now we can do matrix operations. Suppose we already have A now. We have, this is the A matrix 2021, 22, 23, 24, 25. And now let us create one more matrix, like suppose B. We have created this matrix B, and both the matrices have same dimensions. That is 3 rows and 2 columns. So now let we use this command called cbind. This cbind command is used for joining matrices by column. So what this command will do, this will put B below A. That is, it will uh, binding the two matrices by column. That is, one column of the first column of B will be under the first column of A, and the second column of B will be under the second column of B. So let us see what the values come. Now see, I haven't assigned any variable to this cbind. So if I don't assign any variable to the cbind, so this variable won't be saved anywhere. It will just give the output. Because I am just typing cbind A and B, so it will just I think there is some cbind has. Okay, sorry, my bad. I think R. Sorry, this is my mistake. Cbind will be joining matrices by columns. Like this means matrices side by side. That is, the column of B will be beside the next to the column of A. Okay. So this is how cbind works. Okay, the first one. You can see this is the matrix A 20, 21, 22, 23, 24, 25. When you use cbind, the columns of B will be put next to columns of A. This is how cbind works. This is binding by column. And this is rbind. This is used for rbind is joining the matrices by rows. That is, the rows of C will be put below the rows of A. This is how rbind works. Okay. Now I haven't saved these variables after binding A and B into any variable. So this variable is not saved. So if you want to use this matrix again, you will have to like assign it to some variable. Suppose C. So if I assign, so now if I run, you can see the value has been assigned to this variable C, and this C variable is it is appearing here in the environment window. You can call this variable C later when you are using the code. Okay, so this is about binding the two matrices. The third thing is matrix multiplication. So one thing is, there is a normal matrix multiplication, that is how two matrices are multiplied, and there is something called element wise matrix multiplication. So we know what are values of A and B. So if you just type A and this star symbol into B, this means A is multiplied by B element wise, not as a matrix. Okay. When you are multiplying element wise, let's see. We have assigned C. We'll put, let us visualize C. You can see. So you can see okay, data variables. Okay, you can see the first value of a is 20 and the first value of this. Okay, I haven't visualized. Okay, okay, let us visualize a and b first. Okay, so these are a and b. You can see the first value of a is 20, the first value of b is 2. So when you are simply multiplying a and b, it will be multiply first value into first value, second value into second value. It's like multiplying element wise. So you can see 20 into 2, so 40 is appearing here. Then 21 into 3, so 63 is appearing here. It's like multiplying element wise. So this is matrix multiplication by element wise. Now if we want to do the actual matrix multiplication, then we have to use this symbol. But you have to remember one thing: when you are multiplying two matrices, the fundamental thing is that the number of columns in A should be equal to number of rows in B. But what happens here? You can see the number of rows in B is 3 and the number of columns in A is 2. So we'll do what? We will use a transpose of the matrix. This T of B will transpose the matrix from 3 by 2 matrix to a 2 by 3 matrix. So we'll run this command. You can see here how B is changed. You can see the number of rows in B is now 2 and number of columns is 3, and it's for A number of rows is 3 and number of columns is 2. So now we can matrix multiply, this the actual matrix multiply A and B by this command percent star percent. This means you are multiplying two matrices A and B by actual matrix multiplication. We give run this command. We have got a variable C. If we type C here, we are getting this value, that is by actual matrix multiplication. What you will get, if you can do the hand calculation and check, if you double check what is the value, but this is how what is the value you will get. We will do the if we do the matrix multiplication of A and B. Okay, so this was about matrix. Okay, before proceeding into conditional statements, I will just introduce another uh, data type in R that is very useful, and it's very useful in Python also. It is called the data frame. So what is a data frame? So data frame is like is a 2D, or it might be it's a 2D thing, data variable only. You can assign a lot of variables to uh, and you can save a lot of variables in a matrix kind of form. But the thing is that in matrix we only have numbers. That is, all the values in the matrix should be of the same data type. That is, it might should be integer, or it might be real, or it might be a natural number. But when you're using data frame, the data types can be different. We can have categorical variable like A, B, C, D. We can have numerical variables. We can have date and time also. So we can also have this uh, colors. We can have uh, what are the other data types? We can have colors, and we can have numbers. We can have in date and time. We can have categorical variables. So different types of data variables, so we can store in a data frame. So how do we write a data frame? So if you write, you can write in this form. Write A, so write data dot frame. Okay, now this is how you like assign data frame. Suppose we want the first variable to be um, date. Okay, we can write sequence dot date. We can write sequence dot date, means it will create a sequence of date from, suppose okay, you can also use the help menu here. Suppose we want to write the sequence dot date command. You want to use that command. So how do we write the command for creating a vector of dates? So we'll just write sequence. These values comes, you can just click on here, you can see. So It is used to generate regular sequences of dates. So how do you what are the commands? From, to, by, and length out and along with. From is like the starting date, to is the end date, and by is the increment of the sequence. So there is some example. Suppose we can use this example. Uh, okay, so let us try like 2021 02, and let us skip 2023 only. This is the ninth month, that is September, and let us do it from 20. Okay, now this is the first. Now the end date is 2023. Let's skip today. That let us skip 25 only, and we will give days. That is what is the difference between the incremental the difference between and the two values in the array. So we have given days means like it will create a data frame in days. So we want to see what is being created. Just select this thing, and if you do Control C, and you can do Control paste here, and just press enter. Okay. So from must be a date object. So we have to give this. So we have to give this command as dot date. So if we simply write this anything in the form of date, it doesn't take date. So when we have written in this video, one second. Okay. Yeah, when we have written just this date without mentioning anything, it doesn't recognize it as a date. So it recognizes it as a categorical variable. So we have to write as dot date to give this value as a date. Again, as dot date, you can give this command, and we have given this. Now let us see what comes. So given this, you can see the 6 dates are generated from 20 September 2023 to 25 September 2023. Okay, so the first column we got as date. The second column, let us give somewhat. Let us give some variable, maybe rainfall. Okay, daily rainfall we want. So it is equal to, you give some value, and we create a vector. Suppose 101.2 25.5. So how many on three? I've written 7. 6 values are there. Yeah, 6 values are there. We have got rainfall. So we can also say rainfall time. When this is a, now let us create a categorical variable. Categorical means like it will not be a number, it will be something in letters. So we can say high. Again this sense high. Okay. So you can see there are 3 types of variables in this data frame. Now let us run this line of code. You put Control Enter. This data frame A has been created. So you can go here, and if you click on it, you can see for the first date, you can see this is a date column. You can, if you just put your cursor here, it will show it is a date column. Then we have rainfall. On that day there is this rainfall, and rainfall type is high. So again, second date, some value and some high. So you can like give any number of columns, any number of rows, and the best thing is that you can keep any type of variable in this data frame. So, and when you're yeah, you have any question, you can ask. Sandhya, like you have raised your hand. You have any question? Okay, if you don't have any question, then I will proceed. Okay, this was about creating a data frame, and when you're working with like lot of data in your project or anything in your work, so always try to save data in terms of data frame. You can use a lot of variables, and you can save your space. Like instead of creating a lot of vectors, you can put all the vectors in one data frame, and then you can run your function or anything code to each column or each row of the data frame, and you can get your results. Okay, so this is our data frame. Now we will see like what are conditional statements and what are loops. So conditional statement is like you are using some if else condition, and based on that condition you can get some value. Suppose we assign some this value of 10 to a variable x. Okay, x is equal to 10. Now we have written a code that if x is less than 0, we will print x is a negative number, else print x is a positive number. So this is a syntax of this writing a conditional statement. Like if in the normal bracket, what is the condition that you want? Then under braces you write what are the commands that you want to run if this condition is true, and this if this condition is false, then you write else and then write the command. You put a cursor here, and if you right, you can see x is a positive number. So based on your requirement, you can put anything like here in the command line. Suppose if x is, I can here I have just written print, so you can also write any something else like y is equals to x star 25 or something like that. Or we can also give one line of print, or we can just like return. I think this will run. If we simply write y, is it work? Yeah. So it's like you write it. You want to print the value of y, you can get this x into 25. That is your x is 10 and 25 is 250. So you can write based on a requirement what you require in the code, and then you can execute the commands. This is about, yeah, if there are suppose multiple conditions. Here we have only one condition as x less than 0. If there are like more variables like x and y and z, and you want to check that if all the variables meet some conditions simultaneously, then you can use these logical operators. That is, suppose use and these two symbol, this symbol is used for getting, and that is both the conditions are met simultaneously. That is x is less than 0 or and y is less than 0 means both the variables are less than 0. Or you can use this symbol slash slash So this means or. So that is if you write the command as x less than 0 and or x y less than 0, like if either of them is less than 0, then it will execute the command, else it won't execute the command. And this exclamation mark is used for not. That is this exclamation you have to use with some other, that is not equals to means it is not equals to, not less than, not greater than, like that. So you can use this exclamation as a condition to get a not equal to condition or not less than or not greater than kind of condition. So here we have, so one example, this is suppose x is 7, I run the command y is 5, z is equals to 2. Now we write this code if x is greater than y and then x is greater than z. You can see both, if both these conditions are met, then print x is greater. I don't think this is recording. Print x is greater. Okay. So we are not using the else. You can use the else command, else. So just run the command. You can see here x is greater than y, x is greater than z, both the conditions are met, so it is printing x is greater. So if we just keep suppose 0 here, okay, if you put this and if you run this, then you can see x is small. Both these conditions are not met, so it is printing x is small. Okay, this is how you use the and command or the or command in the code. You can also use or, I think, let us see what will happen if we use or. X is greater than, suppose we keep x value of 3. Okay, I put x value of 3. In that case, if x is greater than y or x is greater than z, then in that case it has to print x is greater. So yeah, it is printing the first one. Since it is meeting only one condition, the second condition need not be met. So just meeting one condition is enough. In that case, it has to execute the code. So this is how you use this command, like multiple conditions for running in if in conditional, multiple conditional statements. Now there, if you have to execute only one line, that is only given only one condition, then for a vector, here we have seen that we are using it only for scalars, but if you have to run this if else condition for a vector, so in that case we have to use something like use a function called if else. We write this together. So use for checking condition on a vector for every element and selects elements from the vector. So if we have a vector v, it goes from 1 to 6. We have run this command. You can see v. It's a vector from 1 to 6, and we have to see that if else v percent 2 is equals to 0. Now what's percent mean? Percent, if you put 2%, it means the remainder. That is, if each of the element is divided by 2, if the remainder is 0, in that case print even. And if the remainder is not 0, then print odd. Okay, understood? So the first print this coming, you have here used that x is greater. It is for the if command. If you run the if command, we have given some output. So this part of if command will be coming in the first one here, for the first condition here, that is a true vector, and the second part will be coming as the part of else. So if it is equals to 0, write as even. If it is not equal to 0, write as odd. So, and you have to see the remainder. So let us see if we what we get if we run this. So we have run this code. We can see for the first, if 1% divider of remainder, if we divide 1 by 2 is odd, is 1, so it is returning odd. If we divide 2 by 2, the remainder is 0, so it is running, it is returning even. If 3 is divided by 2, the remainder is 1, so it is returning odd. So it's like that. You want to run a condition for each element of the vector. In that case, we have to use this if else command. So this was about if else, and lastly, there is the most important thing in any coding language is the use of loops. That is, you want to run a condition for a specific number of times. So in that case, we use a loop. Suppose one thing is the type of loop is a for loop, and the second is the while loop. So when you use a for loop, the syntax is like for in the inside small bracket is suppose right I in 1 to 5. Suppose I goes from 1 to 5, and yeah, most important thing when we are giving a condition in the loop, it will be always in terms of integers. It won't go in real numbers. That is 1 2 3, it will go only in the integer form. It won't go into real number form. So I in 1 to 5 means the index of I will, that is index I will be going from 1 to 5 to 1 2 3 4 5, and if for each of the value of I, it will be returning y, that is returning this y value as I cube, that is so I value to the power 3 divided by 3, and then we'll print the values of y. So let us see what we get here. We have written, so you can see for each value of I, if you run this code, you are getting a value of y, and this y value are being printed here. Okay, this is the for loop, and the last thing is the while loop. So while running a while loop is like you first give a value to the index, that is we assign that I is 1. So now we have to run the condition like while I is less than equal to 5. We'll directly increment here. I think I time formatted. Thing is that we initialize the value of I. Now we put a condition when I is less than equal to 5. We run, we put input of give a value of y, that is I cube by 3, print the value of y, and then we'll increment I. That is first initially I is 1, we have assigned 1 here. Then if we for a second argument I will be 2, that is I plus 1. It will run the code, then I plus 3, I plus I 1, that is 2 plus 1 will be 3. It will run the code till the I is less than equal to 5. Till I is equals to 5, it will run this code. After I is equal to 5, it will end the code and it will return all the values. Okay, this is how you use a while loop. Okay, these are some basics of running a code in R. There are a lot of other things. I cannot cover everything in this course because uh, this teaching the language, only the language is not a part of this course. You can get there are a lot of tutorial videos. You can also attend some courses like data science in R or statistical analysis in R. You can attend those courses, and you can get a more detailed experience of the software. Okay, now I'll be proceeding to genetic algorithm. Before proceeding, if there are any doubts, you can ask me now. Do you have any doubts?
Sir, in my system, RStudio software is not installed, sir. Is there any shortcut procedure, sir?
There is no shortcut procedure. The thing is that like you have to go to this site and just install RStudio website. You can like yeah, you have to first check. Okay, let me see.
RStudio IDE.
1 second. So did you check if your system is a 32-bit system or a 64-bit system? The thing
Yes,
is
sir.
that RStudio has two forms. One is a 64-bit and one is a 32-bit. So based on that, you have to install the version of RStudio. So check your system, this one, what are system specifications, and install that version of RStudio only. Okay. RStudio is both 64 and 32-bit. If you try to install a 64-bit RStudio in a 32-bit system, then RStudio won't work. Okay, try to install. I think it's very simple, just installing the software. If you just click on the download link, it will install that version, and then you can just follow the commands, basic commands, what shows after, like while installing any software in a Windows system.
What are the program we are writing? We can store it in a file, sir. Each program.
Are these programs? Yeah, yeah,
Ah,
yeah,
yes.
I will share it in that Google Drive. You have, I share na every week lecture.
Okay.
I'll share it the files as a, I'll publish it as a file, and then yeah, I will share it. Not an issue. Okay. Okay, then yeah, we'll proceed
Sir,
to, yes,
so only when we know the
yeah.
read this R, sir. Only if we know the basics of C++, we can we can understand the coding of this. Is thing like that?
Yeah, you know C++ or like you want to learn C++? I didn't understand.
No, I don't know C++ actually. If I don't know, can I understand all these basics?
Yeah. The thing is that R and Python are much easier versions of coding softwares. The thing is that if you have to run these simple things in C++, we have to
Yes.
write around 40-50 lines of code. But while using R, the syntax is very simple, and it is like very simple compared to C++. So yeah, you can learn this R without having knowledge of C++. Not an issue at all. In fact, it
Okay,
is
sir. Thank you, sir.
much easy to learn R and Python compared to C++. Yeah,
Okay, sir. Thank you.
yeah. Okay, then let's proceed to this genetic algorithm. I think sir told like how to install this package. So I have already installed in my system. So okay, before proceeding, let us clear the console here. I'll also clear all the variables here so that we'll proceed. After clearing the variables, will free up space from your memory, and it is good that your system will run faster. So like installing this genetic algorithm package, so you have to use this command, install the packages GA. I won't be running it because I have already installed the package. Now the second command is, after installing, you have to load the package in your code. That if you want to use that package, you have to load the package. So just use this command, library GA. If you run, so GA is being I think it is show here. Yeah, you can see if you have loaded the package, you can see this package will be given tick mark in this package window, in this fourth window. So whatever the packages you're using in your code, in your script, everything will be given by a tick mark here, and you can see which are the packages that are being used. So you can see if we use this library command, this GA package has been loaded, and you can use this package for running anything in your code. Okay, anything else you have to ask, or okay, then I will proceed. There are a few more commands. I think these commands are taught in the class. That is greater than equal to, how to use this. And then these are some other commands like absolute, gives the absolute value of a number. Square root gives the square root. Logarithm, if you use simple log, it will give natural logarithm. Log 10 will give the logarithm to the base 10. Log 2 will give the logarithm to the base 2. The sine, cos, tan, arc tan. Arc tan means tan inverse. Arc sine means sine inverse. A cos means cos inverse. So these are basic trigonometrical commands you can use. Okay, now yeah, let's proceed to GA. Okay, before proceeding to GA, let us solve these basic questions. Few basic questions only. Yeah. A few basic questions in R. So like here x is given as 1 to 4 and x is greater than 2. what is the output of the following code. So when you are using this greater than 2, it means it is writing running a logical operator. So let us run this code in the. So we'll run the code here only. I won't be running in the script. So it has generated a vector 1, 2, 3, 4. Now we have to check if x is greater than 2 for each of the element in the vector. If you write this, it will return this command. That is, first two elements are less than 2 and the next two elements are greater than 2. So it is given false, false, true, true. So it is the second option, that is false, false, true, true. This greater than, here I have some, these are logical functions. Greater than equal to, less than equal to. Equal to means you are comparing that if the both two variables are equal. If you have to assign, then you have to use single equal. If so, to avoid confusion, you are using that symbol, that is less than minus. You are using that function, that is that command for assigning variables, assigning a value to a variable. And this equals to means you are comparing, that is if a is equals to b. So for that you can use this command, that is equal to. Okay, so these are logical operators. Then the second question is, x is 1 to 4, y is 6 to 9. What you will get if you divide x by, if you run this command. Okay, again we'll run this code. X is already given, we have 1 to 4. We write y 6 to 9. So y 6, 7, 8, 9. We have to get what is x by y. So this will return the division element wise. That is 1 by 6, 2 by 7, 3 by 8, 4 by 9. So it is dividing all the element by the corresponding element. Okay. It is first by first, second by second, third by third, fourth by fourth. So this is the answer. 0.16 is 0.28, 0.37. So I think, yeah, this is the 0.16, 0.28, 0.37, 0.44. Okay, then again this is a question, that is two vectors m and n are defined as m is equal to c 3 to 4, n equal to c 1 to. What will be the output of the vector z, that is defined as z equal to m star n. Okay, we will write this. M is equal to c 3 to 4, 3 comma 2 comma 4. I think it was 1 comma 2, right? Yeah, c. So now g m star n. So we have already seen this is not matrix multiplication, this is simply multiplying element by element. But the thing is that we have 3 elements in m and 2 elements in n. So what will happen when we are multiplying it by multiplying it this way? So if you press enter, yeah, it will give a warning, that is the two objects are not equal, but the thing is that it will return a value. So it will be repeating, that is first element will multiply by first, second will be multiplied by second. When we are multiplying the third, again it will multiply by the first one only. So it will be coming in the rotation pattern. So 3 into 1 is 3, 2 into 2 is 4, 4 into 1 is 4. So if you are multiplying it by a vector of shorter length, for the values that there is no corresponding value in the second vector, it will be multiplied by the that is previous vector, that is the after rotation what we get. Okay, this was about these things. Okay, now let us proceed to genetic algorithm. Okay, I will clear this window. Okay, so I have installed this GA. I've loaded the GA package. So the thing is that we have this function x square plus x into cos x. So we have to, what we have to do, we have to like, yeah, let me visualizing it. What we have to do, we have to get the maximum value of the function. So we've defined this function here, that is we write f is a function of x. And how is x defined? X is defined as x square plus x into cos. This is a syntax for writing a function. Okay, remember this syntax. Yeah, I'll be sharing the codes, but you have to remember for your assignments and for your exam. Okay, so if I run this, and yeah, I'll clear this thing. If we run this, we will get a function x. That is, when you're getting a function x, the thing is that a function is created. Now, for different values of x, it will be returning one value of f. So what we do, we plot this value of x for the region -10 to 10, and we have value 1000. We have created values for 1000. We are taking 1001 values between this range -10 to 10, and for each value it will be returning a function that is f of x. Okay, and so this is a curve function. The curve function is used to plot the values where there are two variables as x and y, and to plot y in terms of x. So given the color is blue, this is the x lab, means the what we'll be writing in the x-axis, and y lab is the y-axis command. So let's just run this. You can see this is the plot for the function. You can see at x is equals to -10, what you are getting. So it will be 10 square minus 10. That is 100 minus 10, 90. 90 into cos of -10 will be, I think, something cos of plus 10 only. Okay, so for each of the value, for 1001 values inside this range, -10 to 10, you are getting this curve. Suppose if we are not using 1000 values, suppose we are using only 10 values. In that case, you will get a very coarse kind of curve. Let us see what we get. You can see the number of values between the range -10 to 10 is very less. So that's why you are not getting a true form of the curve, but you will be giving some format like, okay, the mean values of the curve will be like this. So that's why you are taking very high number of values between the range -10 to 10. We will use the curve function and will give this proper curve format. Okay, so now we will run the GA command. Okay, I will help. So how GA is used? Yeah, genetic algorithm. I think this is not. I think small GA. Yeah, this is how you run a genetic algorithm optimization method for running this code. Now you can see how beautifully this function is defined in R. Like when you are using it for MATLAB, some commands you have to give like manually, and some like write some functions. But you can see in this function in R, it has incorporated everything, all the parameters that you can give or think of to input to a GA function. The first thing is the type. It is we are in the binary GA, real value GA, or a permutation GA. Permutation GA we haven't learned, that is out of scope of the syllabus. We have learned binary GA and real value GA. So we'll be using real value GA here because it is better in terms of when you're getting dealing with continuous values. Secondly, we need the fitness function. The most important thing in GA is first you define a fitness function. We'll then do whatever this selection, mutation, crossover, mutation, everything on the fitness function only, and we'll then get the best solution from the fitness function. So we have the fitness function, then we define the lower and upper, that is in what range we want to optimize the fitness function, that is from, we give the upper limit and lower limit. N bits we can define ourselves. We can suppose set a bit size of 10 or 20 or anything, or you can just leave it uh, unassigned. In that case, the computer will assign based on your upper limit and lower limit. The computer will assign a very suitable bit size for running the code efficiently. So this is again one thing. This, like when you are not assigning the code is assigning itself, and to make the code run efficiently. So these are also advantages in this GA function in R. So these are the default function, the population, selection, crossover. Then we have this population size. By default, the population size is given as 50. You can always change that. You can use 100, 200, 1000 based on your requirement. That is a more complex problem, you'll need a higher population size. For a more simple problem, like you can solve it with small population size also. Like increasing population size won't like improve your solution much. Then there is called P crossover, that is probability of crossover. We have discussed before also that when you're doing crossover, we'll give some probability. Like for this probability of these values only, we will be going into the crossover. So we are giving it as 0.8, and there is the P of mutation, that is probability of mutation. We give a probability, we keep it as very low, that is only one, only small, very for small number, for very few number of strings, a few number of solutions only we want to go it for mutation, and that probability of mutation is nearly kept very low. It is kept in a range of 0 to 0.1. To maximum is 0.1, never keep it greater than 0.1. You can keep 0.05, 0.07, 0.202, anything in between 0 to 0.1. Next, there is elitism. Elitism is, we have discussed, that is some solutions we want to extract so that these best solutions are preserved for the till the last iteration. So we can this function is assigned here only, is assigned by the code, that is maximum of 1 or round up population size into 0.05. So if we have a population size of suppose 100, 100 into 0.05 will be 5. So 5 is greater than 1. So we will be like maximum, like 5 solutions will be retained as for keeping the best solution till the last iteration. And suppose if a population size is very low, in that case this multiplying it by 0.05 is very low. In that case it will attain only, keep only one solution as the elitism, for elitism. There are other iterations like update population. Here we are not updating population every time. So there are many research problems where like the scientists or this uh, people want to solve like complex problems. They want to update the population for every iteration to see how is the solution behaving. So these are some other commands, and parallel command is like running the parts of the code in different cores of your system. Suppose you have in your computer, you have this CPU and GPU. Like GPU is this graphics processing unit. This NVIDIA, AMD, they have this graphics card like 4 GB graphics, 10 GB graphics, like that. And also you have the CPU, which is like your 10 this one 10 core system, 16 core system, like that. So what parallel does, it will be dividing the work into different cores and the graphics and the graphics processing unit, and in that way it will be running the code more efficiently because it is dividing the work into different parts of the CPU. Rather than running one by one, it will be running everything in parallel and give the solution in a more efficient manner. So, and there is something called monitor function we will discuss while solving this. Oh yeah, this was about this function. So like there are some advanced commands. We won't be needing these advanced commands here. We'll be using for the basic commands only here. So for our work, we need, so first we need to give the type as real value. We give the fitness function as f. This is the function. The function is defined as x square plus x into cos x. The lower value is -10, the upper value is +10. So let us run the, so GA has run and it ran till 100 iteration, and for each of the iteration it is giving the best solution. That is for the each iteration the population is divided into the some solutions into the best solution and some into the like subsequent solutions. So we will give, next command is summary. That is what is the summary of the algorithm that we ran. So we write summary, we'll get this. So we have got type equal real value. We have a population size of 50 because we haven't changed the population size here. Then we have a number of generations equals to 100 because we have it is I think there is, it is yeah, max iteration. Yeah, this command, this max iteration is the number of generations or the number of iterations we are doing for the code. It is by default it is 100. You can change it to 200, 1000 based on a requirement. But the thing is that just increasing won't be increasing the number of iterations won't be making the solution better sometimes. So when your solution is very simple or the fitness function is not that complex, even running for 100 or 50 solutions also you will get the optimal solution. So this is there's an irrealism is 2 because 50 into 0.05 is 0.25. So we are giving two solutions are returned for irrealism. Crossover probability 0.8, mutation probability 0.1, search domain x1 minus 10 to 10. So 100, the fitness function value for the best solution is 47.7, and this is written for this value of x is equal to 6.5. Okay, so if you write GA at the solution, it will give the solution at what value we are getting the optimal. So we already had this plot here, right? We have this curve, and we know that GA always tries to return the global optimal solution. So the global, if you run this abline is a command that is it will run, it will draw a line at whatever command we give. We are given a given v equal to g at the rate solution. G at the rate solution is what? It is 6.5, and v means what? Vertical line. If you give a ebb line v equal to something value, it will draw a vertical line at that coordinate. So we have 6.5 here. So ebb line will draw a line at 6.5. So you can see this. Now if you instead of v, if you give h, it will do what? It will draw a horizontal line in that case. Okay, so at the solution value 6.5, it has returned this, it has drawn this line, and we want to see at what point this line intersects the curve. So we have to write this command points g at the solution, that is at x, and what is the fitness value f of x at that solution, g at the fitness value into pch is the size of the point, that is how thick you want it. You can put it 20 is the standard size, and yeah, you can give the color as red. So you can see it has given this drawn this point at the point where the that is the ebb line is intersecting the curve. Okay, so this is a way, and also you can do the plot of GA. If you simply, this is the plot of GA. This has been taught in class. I am just brushing it up. That is the initially for the first iteration, you can see the fitness value is here, and after around 20, 40 iterations, you can see the mean values are here, and after only very few iterations, only the best value is coming very near to this the fitness value. The thing is that even after running for 50 iterations, also you can get the optimal value. Did not run for 100 iterations, so you have to see that based on your curve. So after running a GA, you can see like even after 50 iterations, you are getting a very good solution. So you need not run for 100 to save time and also save computational efficiency in your system. So this was the just using the GA command without changing any parameters in the GA. Now we can also change the parameters in the GA, and these GA problems are based on the unconstrained. Okay. So next we will change some parameters in the GA function. The type real value we keep it like that. The fitness function is the same. Lower and upper limit are same. Population size initially it was 50. Let us increase the population size to 100, and let us increase the crossover probability to 0.9. Mutation probability is 0.05, and number of generations as 150. We have changed this, and let us run the code. We ran the code, and I think on if we can see the results, I think the initial funnel result is, yeah, to some accuracy. I think even after the 9th or 10th iteration only, you are getting a very good solution as 47.705. So after that, the solution is hardly improving much. So you can keep it till 20 iterations also if you're getting this. You can see for running 20 iterations also, you are getting a very good solution after 20 iterations. So you did not run for so many iterations. Just a second, okay. Okay, so this was about like even after running for 20 iterations, we are getting a very good solution for the genetical for this problem. So let us see the summary of the GA. We can see the summary that the crossover we have given the number of population size as 100, number of generations is 20, elitism is 5 because 0.05 into the 100 we have given the population size as 100, right? And in the function elitism is given as one second. Yeah. So now if we run this command ga at the solution, it will show the solution is 6.56 that we obtained in the previous method also. Here also you are getting the optimal solution, but at a very fewer number of iterations. Now, like suppose if we want to monitor the progress, that like we are running for different iterations, for each of the iteration, like how is the solution varying. So we'll write a monitor function. The function will be defined as function of object. The object will be the that genetic algorithm object. Like when you're running this GA function, it will be converting it to a GA object. So when you're running this object, the monitor function will take this object as the input in the function, and then it will run this command. First, it will draw the curve that we have already plotted. This curve I think I have shown here. Yeah, this curve of f, a limit from -10 to 10 into 1001 of 1000 and data points, x lab is x, y lab is f of x, and color is blue. So this curve will be plotting, function f will be plotted, -10 to 10 is the range, and it will be giving the this one title. And main means the title will be giving generation equal to number, like for each generation how the solutions are varying. So for each generation it will be showing the points in the curve. Then for each generation, like for each iteration, will be showing the points. The points will be object at the rate population and object at the rate fitness. For each generation, will be showing the number of the population, all the values in that population, what are the values, and for each population value, will be showing the fitness. And PCH is 8. It will be showing the type of point. Color is equal to 4 means it will be showing in green. Then rug means it will be showing what is the corresponding x value. And system.sleep, I am putting this commands as point to so that we want to see the solution. If we don't put this command, then it will run, the code will be running so fast that we won't be able to visualize with our naked eye. That's why we are keeping a lag of 0.2 seconds so that we can see for each iteration how it is varying. So we run this function now. What we change in the GA function, everything else will be same. We'll be just including this monitor function. This monitor equals to monitor, and we'll see how the solution is progressing. We'll put enter. You can see generation is varying here. You can see the solutions for each generation. You can see the solutions are varying, and you can see the most of the solutions are accumulating at the global maxima. At the global maxima, you can see most of the solutions are accumulating after end of each generation. And after end of 100 generation, you can see what is the solution. So let us wait till 100 iteration. Yeah, so 100 iterations are done. You can see there are two solutions here because it's also a maxima, but most of the solutions are accumulated in the global maxima. So that's why genetic algorithm is a very good method for getting global optima in case of this optimization problems. Again, summary GA will give the same thing, GA address solution will give the same thing. So this was about single variable problem. So now let us see how do we do it for the two variable problem. So if there are two variables, that is x1 and x2, and so we'll define the function like this. First we will see how the function looks and by plotting it. So it is a function of two variables x1 and x2, and this is the function that is x2 plus x1 square minus 11 whole square, and x2 square plus x1 minus 7 whole square. So we'll run this function. You can see the function is coming here, function of x1 x2, and we assign the values x1 and x2 as a as a sequence vector from -6 to +6 and an increment of 0.1. We got this. We got x1 and x2. It is 121 values from 1 to 121, -6 to +6, and then so now what we have the x1 x2 values, and we want the function value at each value of x1 and x2. So for getting that, we'll use this outer command. Outer will do what? For each value of x1 and x2, it will give the function, that is function value for each of these values. So we run this command. You can see we'll get fp. Fp is a 2 by 2 matrix. If you just click on it, you can see it's a 2 by 2 matrix, and for each x1 and x2, it will be returning some value. On these columns we have x1, here we have x2, and after running the function f, it will be returning a value for each of the value of x1 and x2. So we got a 2D we got a matrix for this function. Now this command is used for visualizing this function in 3D. So P or SP perspective. So theta angle is the angle at which we want to visualize. X1, x2, and fp are the values that we assign, and phi is the rotation about the z-axis. So we'll just run this command and see how it shows. I think this is the angle. You can see the function is plotted in this manner. So x1 is here, x2 is this axis, and the z-axis is the fp. So it's very difficult to visualize the maxima and minima sometimes in a 3D function. So that's why we'll try to plot it as a contour plot. What a contour plot does? So this is the commands, that is again x1, x2, fp, and levels is 100, and color is blue. So this is a contour plot. You can see at these contours, that is at 20, 20 and 20, like you can see at these values the function is getting a minimum value, that is at values suppose around near 4, that is around 3.7 or something like that in x1, and for x2 around suppose 2 or like in this range. So we'll get a minimum value here for these values of x1 and x2. So that's why the contour plot is showing that around those values the function is having the minimum. So if we increase the number of levels, suppose we make it 500, so we'll get a finer resolution contour plot. Let us see what will happen if we increase the n levels to 500. You can see now, if we increase the n levels, the contours are becoming denser, in more dense near the optima. So these two optima are separated. You can see here optima is localized here, one optima is localized here, one optima is localized here, and one optima is localized here. That is all the minimas. So if we increase the number of levels to 1000, then we'll get a more finer resolution of the function. So this is how a contour plot is used to visualize the function. You can let us keep it to 100, because if you give it to 500, it's like very difficult to visualize sometimes. Or let's keep it to 200. 200 is better, right? It's easy to visualize now. So now what we do? What happens in here, we have two variables, but in genetic algorithm, when we are putting the function as an input to genetic algorithm, we cannot give two variables as input. So in that case, what we do, we have only one variable. That one variable is introduced as a vector. When we have a vector, it will have a first element and a second element. So we can have n number of elements in a vector. So we put each element, each value as an element in the vector. If you input these values as an element in a vector, you can get the commands here. So let us write here what we had, x2 plus x1 square minus 11. So what we do, we give an input vector x. It has two values, that is one first and second. The second value corresponds to x2, and the first value corresponds to x1. So we write this as x2 plus x1, and why square braces? Square braces are used to get the element. I showed in the first code only that we use the square braces to extract any index element of a vector. The second element is extracted as x2, first element as x1. So like that, we are writing the function again in terms of x. We write the function here, we put enter. Now we write the GA code. So write the GA function, type is real value same, fitness is f, now lower. So now we have a vector instead of a scalar. So here before we had only one value of lower, but we have two values now for the vector. So we'll be putting two values as a vector. It's -6 and -6, and the upper limit is c of 6, 6. That is the upper limit of both the elements in the vector. And let us keep the population size as 200, and we won't be changing the other parameters here. So we run the GA code. It will run till the 100 iterations, and let us see the control plot we already have, and we'll see the point. Yeah, and we'll see the point that is giving the solution. Yeah, you can see the optimal point is coming as here at this point. This is the global optima, global minima for the function in this range. It is -6 to 6, and -6 to 6 for both the variables, x1 -6 to 6 and x2 also -6 to 6. The summary of the GA, you can see. So it is at x1 equal to 2.99 and x2 equal to at 2.00. The function is having a minimum value, as optimal value. And yeah, one more thing I forgot to mention here, it is a minimization function. You can see here, you can see we have only have minima in this function, we don't have a maxima. So we have to visualize the function like this. So if we have a minima, we'll multiply. If we have a minima, we'll multiply the plot in the function by a negative sign, because I already discussed in the concepts in last class that when you are using genetic algorithm is designed to get the maxima. So we'll multiply it by minus so that we optimize the maxima, and if we get the maxima, if we multiply it by minus, we'll get the solution for the minima only. Okay, now for this code also we are writing this monitor function similarly to the previous one. We'll write the monitor function and we'll run the GA again with the monitor function, and we'll see how it is varying. Yeah, you can see how the solutions are varying for each iteration in the GA. Okay, we'll see. So you can see the solutions are accumulating near the global optima here. That is, most of the solutions are accumulating for each population near the global optima. Some solutions will be retained here also, but yeah, most of the solutions will be retained. Will be accumulating near the global optima. That is a global minima in this function. There are 65th. Yeah, let's wait till 100 because we have set the number of iterations as 100. Okay, now we have seen after 100 iteration, most of the solutions are here. Some solutions are also near this solution, but mostly here. And among these, the best solution will be returned. The solution having the highest fitness value will be returned as the best solution after the 100 iteration. Okay. So this was about how running a code for univariate and bivariate problem for solving a bivariate optimization problem in GA. We'll be solving one or two problems. Before that, if you have any doubts, you can ask me now, like in this whatever I have done till now. Any doubts? Okay. If there are no doubts, we'll proceed to solve one or two problems, and at last we'll see the constant optimization problem, and we'll just see through it in a very brisk manner. So
How
this,
to install the GA package, sir?
yeah, yeah. What is
Good.
the doubt?
How to install the GA package in a RStudio software?
Yeah, yeah, I showed here, no, this command install dot packages. If you put GA, you
Yes,
can
sir.
get.
I will try that command, sir. But warning message is there, sir. R tools is required to build R packages, but is not currently installed.
Actually, I think you have given this command. When you are writing this command, like it automatically gives installed. This
Okay.
install, so if this is coming install the packages, it will showing that it will show the package, not install the package. So remove ed and just type install the packages. Okay.
In the place of installed, you have to place the install.
Yeah, just put install. Okay, and one more way of is just go to packages here, go
Okay.
to this install command here, and you can write the, suppose you want GA. Just select here and click install. It's also a convenient way of installing. Okay.
Okay. Okay, sir.
Okay, then yeah, let us see one or two problems. I think, yeah, so this is the problem here we are trying to solve. So it is given minimize the function f of x square plus x plus 1 sine x plus sine of 2x. So range is minus 10 to 10, a single variable function, so you won't be having much problem. So we write the function, so we have to minimize, so we write put here a minus sign in before, x square plus x plus 1 into sine x plus sine of 2 star x. So we put this function, just we do we put enter, then we run the second line of code. We just want to see the curve, how it looks. The curve looks like this. So this function has both a minima as well as a maxima. So if we put minus sign here, we will get the minima. If we just put plus sign here, we will get the maxima. So just remember that. Okay. We want to, for based on the type of problem, it is if it is minimization or maximization. If it is we have to minimization, we have to multiply the fitness function by minus. Okay. So let's proceed. We just give a monitor function like before, how we defined a curve function here. Then we have to write the points, then rug function, and finally the system.sleep to see how the solutions are varying. Okay. I put this
Excuse me,
enter.
sir. Excuse me, sir. For minimization, we have to put minus, na?
Yes, 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 yeah.
Or maxima, or for maximize, you have to put minus.
Minima. For minimization, you have to put minus.
Okay.
Because by default, genetic algorithm is a maximization
Okay.
type of.
Okay. Okay. Okay.
For don't confuse with a classical optimization. In classical optimization, when you're doing in classical optimization, I told now we have to convert it to convex problem. There we have to convert this
Okay.
maximization to minimization.
Okay.
But for
Okay, sir.
genetic algorithm, it's a reverse.
Okay.
Okay, system.sleep is 2, and then yeah, we write the GA function. type is real valued, fitness is f, lower is equal to -10, upper is +10. Number of bits here we can assign as 10 because it is given in the question only, and monitor equal to monitor. You run this command and we will see how it is varying. I think it is still getting the maxima only. Okay, so there are some solutions in the maxima and some solutions in the minima. So what does our GA return? Okay, so our GA is returning 9.99. So it is having a minima at this value. But I have already told that GA is by default a maximization problem. So we are giving minus, but even after that, the GA is trying to get a solution. It is having population here also. It is not having most of the populations here. So that is one of the disadvantages sometimes, like when there are too many maximas and only one minima, the GA might be sometimes get confused, like whether to get the maxima only or to get the minima. That is one slight disadvantage sometimes, but if you define the fitness function and you define the range very properly and you define number of iterations properly, you will get the solution. So GA address solution, it will be 9.99 at this point, 9.99. And if you write, if you keep a line command, you can see. Oh, sorry, 9.99 is giving the maxima. 1 second. It should come around 8.08, right? Hmm. Why is it not returning minus f? If we get f here, okay, let's see if we remove the what the minus sign, what we get. Curve is same, monitor is same. Let us. Okay, yeah. One thing. Sorry, that was I did some visualization mistake. So this is like when you are putting the function as plus, we are not using the minus, and while plotting the curve, we are using f only, right? So if we multiply it by minus here, then the curve will also be reversed, right? You are, if you're not multiplying with by minus, this is the original curve. That is, you have a minima at this point and a minima at this point in the range -10 to 10, and a maxima at this point. But now, yeah, if we now multiply it by minus, the function will also be reversed. That is, you can see, yeah. So now function is reversed. So we have to obtain the maximum. The GA is designed to obtain the maxima. So it will try to search the maxima here, and will try to search the maxima here. So based on this, the GA is operating, and that's why we are getting values at this point and at here. We'll get the solution. So don't get confused when you are plotting the curve. Okay. So when you are doing using this curve function, you are getting the solution in that manner only, because you are using the function f as the negative of the initial fitness function.
We will get the minima at the top in the figure.
Yes, we'll get the minima at the top because you are reversing the function value. Putting the minus, we are plotting the curve as the function value that is already negative, so it is reversing. Okay, taking a mirror image of the function. So we are getting a, this is originally, you can see the okay, here it will be showing till 100 only. Originally it is a minima, right? I showed in that curve, and here it is the here also it is a minima, but this was a maxima. But the curve is reversed, and so we are getting the values here and here because it is converted to a maximization problem. Okay, understood? Okay, so app line and everything we got at 9.99. We are getting the solution. Now our second solution, second problem. So this is a two variable problem. The function is we have to optimize this function. F is equal to 0.26 into x square plus y square minus 0.48 xy. So f is equal to xy. So we'll just try to plot this function. 0.26 x square plus y square plus minus 0.48 xy. Put fp, x and y as minus 10 to 10 again given, and we put outer function to get the values of the function at each of x and y. Then perspiration function to get the perspective function to get the 3D print. Yeah, it will come, I think. Yeah, so this is the function. I think you can. Yeah, let us try to zoom. Yeah, see the function. This is the function value x, y, and the fp. You can see there is a maxima here, there is a maxima here, and in between there is a minima somewhere in the middle. And let us get the contour plot. This is the this is the contour plot. You can have diagonally we have the minima and the maximas at the corners. Okay, so we have to minimize this function. So we will be multiplying the function by negative sign, and it is a two variable function, so we cannot define two variables. So we'll take a vector and take the first element and second element of the vector as x and y. So let us define a vector x. We have written the function in this format. We write the GA. Again, population size we are taking 200 here because it's mentioned in the question. This is the the lower limit is minus 10, upper limit is 10, 10. Population size is 200, fitness is f, and type is real value. Given this, now let us see the contour. I think, oh sorry, this contour is x, y. X, y. We have the contour function and we want the points. Yes. Yeah, so given the minus, or the points we will be getting as the negative of this function, so we get a point at the minima. So now if we have 1000 levels, we will get a more finer resolution contour map, and we will see for that. I think, is it coming? Yeah, this is a finer resolution contour map. You can see the minima should be somewhere here, so we write points of this function. You can see the minima is at the center because the contour is covering at the center of the okay. Yeah, the negative sign is there. I have mentioned here, right? In the function this negative is there, right? While defining the function only, we are multiplying the whole function fitness value by negative sign. Because in minimization, like initial, this is the question that fx equals. So I think I have. Yeah. This is the function. This is the range minus 10 to 10. So this whole function is this multiplied by minus 1. Okay, whole function is multiplied by minus because we have to find the minima. If we have to find the maxima, we need not multiply it by minus. So we have multiplied the fitness function here only with the minus. You can see the minus symbol here. Then we are using the GA on this function. That is, after multiplying the fitness function by minus, we are applying the GA to get the optima. So summary of GA you can get, it is around 0.003, 0.002, that is near 0. So here the solution is 0.003 and 0.002, and these are the solution to the problem. You can also use this monitor function here also to monitor the progress for each generation. I won't be doing it. You can run it. I'll share the code anyways, so you can run it on your PC to see how the solution is varying for each population. I hope this is clear. This was about unconstrained GA. So I'll quickly go through the constrained GA problem. So this is also done in class. I will just brush up if there are any, like to clarify if there are any doubts. So we have already installed a package GA, so we won't be installing again. So we'll just load the library GA. Here also it is already loaded. So if we won't be writing this, we won't be running this command again, since our function is already, since our package is already loaded in our script, loaded in our environment. So this is the function. We have to minimize this function x1 minus 2 whole square plus x2 minus 1 whole square, subject to the constraints x1 plus x2 minus 2 less than or equal to 0 and x1 square minus x2 less than or equal to 0, and the range is minus 5 less than or equal to x1 x2 less than or equal to 5. It is minus 1 minus 5 to plus 5. Okay, so let us define the function. This function x1 x2. We just need to first want to see the plot how it is varying, and then we'll do the problem. So we define x1 as we define the function. We define x1 x2, that is sequence minus 5 to 5, increment by 0.1. We get the f function values at its x1 x2. We get a contour plot. We get this contour plot for x1 x2 in the range minus 5 to 5. Then we first plot one constant. The first constant is x1 plus x2 minus 2 is less than 0. So how do we can write it also as x2 less than equal to 2 minus x, right? So we'll see the function where x2 is equal to 2 minus x. We will see that line, and based on that we will be doing our solution. So x2 is assigned to 2 minus x. This is, we'll plot the line for equal to condition, and then you can see which region it is following. N is equal to 1001, color is equal to 1, color. So that you can see one more thing I have here, I have mentioned color equals to blue, and here I have shown color equals to 1. So either way you can assign colors. The color, each color there is a code number. That is, for 1 corresponds to black, 2 corresponds to red, like that. So for each color there is a coded number, and you can use that coded number for each color. And for this, getting these details, you can get it in Google. Just type our color code, and you can see Google will give a chart. It will show for each color what is the code number. So it's based on a use, like it's convenient to use the color name as blue, black, red, whatever you want, or you can use the color number. So we'll get a straight line. That is, you can see this is the line corresponding to the constraint 1. The second constant is x1 square minus x2 less than or equal to 0. So we'll write constant x1 square equal to x2 equal to x1 square. Yeah, and we'll write get the function here, so you can get this parabolic line. Okay, so this is the function, and we have to make the condition that these values are less than this line and also less than this line. So we have to get the optimal value here. So if you're running the unconstrained problem, the optima will be coming somewhere at this center. But since you are using these constraints, the optima should be somewhere at this intersection point or at this intersection point. So let us see at how do we get the optima. Now this is again a minimization problem. So our function, what we have to multiply it by minus x1 minus 2 whole square and x of 2 minus 1 whole square. We are defining an array as vector x, and we are taking the first and second element. We define f here. Okay, this is for constant problem, and we write the function in a different ways. So the function is like, we define f1 as the function minus of the same thing. g1 is x1 plus x2 minus 2, that is x1 plus x2 minus 2. g2 is x1 square minus x2, x1 square minus x2. And now we have to compute f, get f, subject to the condition g1 less than equal to 0 and G2 less than equal to 0, because these are the constant conditions. If these conditions are met, we have to return f1, else return minus 1 into e to the power 4. We are taking a very low number, so that since we are trying to, like, we have already multiplied the function by minus, so we are getting a maximization problem only here. When we're getting a maximization problem, and if the condition is not met, we are putting this value as minus of 10 to the power 4. Minus 1 e4 means equals to 10 to the power minus 4. Okay, just remember this, how we write powers in code. So 10 to the minus 4, we want to, sorry, so not 10 to the power 4, 10 to the power 4 minus of 10 to the power 4. Sorry. Yeah, so we're getting a very small, very highly negative number, so that we are not getting that value in the solution. Okay. This is how we define this function for a constant optimization problem. We run this function. Now we have to use the GA. The fitness function is this function, whole function f. The lower limit is minus 5 comma minus 5. Upper limit is 5 comma 5. Population size you can define. I have defined 100. Maximum iterations, so okay, 200. I can keep 150 also. And let us run the GA. Okay, so we got the solution at what something called minus 1.04. So the points, will get the points at what we are getting the solution. You can see, based on a constant optimization problem, we are getting the optimal solution, optimal minima at this point, where the constraints as well as they are met for this optimization function. Okay, the summary of GA, you can see at what x1 and x2 values you are getting, and GA the solution will show the solution values. You can also use the monitor function here also if you want to monitor the progress of the function, else you can just see the solution. Okay, so this was all about this trying to solve GA in R. If there are any doubts, you can ask me now. I have like around 5 minutes in hand.
Sir,
Yeah, tell me.
sir, in assignment 8, I have doubt in 5 and 6. Do you solve that in the last section? I have missed the last problem solving section.
Assignment 8, I have not solved exactly assignment 8. I have solved some problems from the previous assignment. Okay, if you have doubt, I can have a look.
Yes, sir, 5
Okay,
and 6. Get the idea how to solve that.
okay, 1 second. I will stop presenting the screen and just do it.
Sir, will the recorded version be available for all the sessions?
For all the sessions, I have uploaded the YouTube link. You can get that YouTube link. And the
Where have you
questions
uploaded
there.
that, sir? I'm sorry, where have you uploaded it?
I think NPTEL, there is this in NPTEL website, like in this course website, you can see the problem solving session. There is a whole playlist. So you can see that here, like in the playlist, the YouTube links for each of the session is uploaded there.
Okay, sir, thank you.
And also, there's a drive link also. The drive link will be showing whatever problems I am solving. There's a PDF document of all the problems that have been solved in each problem solving session.
A PDF link, we are getting a mail only.
Okay, and YouTube links are there in that website, like in the NPTEL course website.
Okay, sir.
So yeah, which question? Assignment 8, right? Wait. Okay, week 8. Yeah, which question you had doubt?
So 5 and 6.
5, in a 3 variable problem, the following variable bounds are specified. That question, right? -5 less than x less than equal 10. Okay, a similar question I have solved in the problem solving session. Okay, you can
Yeah,
just
I missed it, sir.
okay, just you can go to the YouTube link. It is there in this website only. You can
Okay.
see below there is this problem solving session mentioned, right? You can click on that. You can all the I think YouTube link is uploaded.
Okay. The sixth one, sir. You have solved that too.
Sixth one is like consider a function f of x square plus x cos x. The maximum values of the function are to be determined. Yeah, similar question I have solved there. Yeah, I have similar plus solve a similar question. You can see that problem solving session and you will get to know.
So books for reference for this NPTEL course.
One book is this one. I think Kalyanmoy Deb, K. Deb. There is this introduction to optimization. You can see that book.
Okay.
And there is for genetic algorithm. You can see that there is a book by Goldberg. I think in Sir has mentioned in the first
Yes,
lecture.
yes, sir has mentioned the other book what you have told. I am not clear.
Goldberg, 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 optimize.
Goldberg.
Yeah.
Sir, question number 2, you have to tell me, sir.
Question number 2 here, like assignment 8.
Yes, sir.
One second. Disadvantages of binary coded genetic algorithms. That's this one.
I think
Actually,
option D is correct, sir. All the above.
Yeah. It should be all of the above. Yeah, I told
But
that in the brief.
it will be mistake of more computation, sir.
Yeah. Again, mistake. This was a typing typing mistake in this paper. Okay, I'll raise the issue in the NPTEL.
sir, also
Okay,
the
okay.
fourth one, sir. It's two, right?
Yeah, fourth one.
Question number 4. It's like away from the parent only, no?
Simulated binary crossover, high value. No. I have discussed this again in the class, so you can in the problem solving class you can see.
Okay,
Okay.
fine. So you have similar questions of 5 and 6 in the problem solving section. Am I right?
Yes.
Okay, thank you so much.
Okay. Okay then. If there are no further doubts, we will close today's session here.